Hi everyone, welcome to Module 3 of Workplace Math 11, Probability. We'll go to page 1 of the notes. Introduction to Probability. Probability is the mathematical term for the likelihood that something will occur. For example, drawing an ace from a deck of cards or picking a purple piece of candy from a bag of assorted colors. An introduction to probability, let's look at an example. The best example for starting to look at this is something we're all familiar with, which is when you flip a coin. You can have heads or you can have tails. So the probability of it being heads can be calculated with this formula. The probability of a certain outcome happening equals the number of possibilities that meet that conclusion divided by the number of equally likely possibilities. This is also phrased sometimes as the number of ways it can happen. Okay. Number of ways that whatever your outcome is that you're looking for, the number of ways it can happen. So for example, the probability of a coin landing on its head, we would write that as probability of heads is 1 over 2, because there are two possible outcomes. One of them is heads, one way to get heads. Okay, so let's look at some more examples. The probability, calculating the probability of a single event happening. Calculate what's the probability of rolling a 1? I'm assuming we're talking about a 6-sided die here. So the probability of 1, well, the possible outcomes are 1, 2, 3, 4, 5, and 6. Those are the things you can roll on a regular 6-sided die. So the probability of 1 is 1 out of 6. Okay, there's only one way to get a 6, or to get a 1 out of the 6 possibilities. What's the probability of rolling a 1 or a 6? So there's a 1, 2, 3, 4, 5, 6. And there are two ways, there are two things we can get that will satisfy our condition, a 1 or a 6. So our probability equals 2 out of 6, because there are 6 possible outcomes and 2 of them satisfy our condition. And we would reduce that to 1 over 3, and we could also write this as a decimal, which is 1 divided by 3, or 0.33. It's actually 3 repeating. Or we could write that as a percent, which is 33%. Okay, and actually I should pop back up here to the 1 over 6. We could write that as a decimal, which is 0.17, and we can write that as 17%. Okay, those are all valid ways of showing the probability. What's the probability of rolling an even number? Okay, well, our possible outcomes are 1, 2, 3, 4, 5, and 6. And if we get a 2 or a 4 or a 6, we've rolled an even number. So the probability of an even number is 3 out of 6, which we would always reduce to 1/2. We could write that as 0.50, or we could write that as 50%. Okay? Let's summarize some things to remember. The probability of an event can only be between, actually I'm going to rephrase that, it's from 1 to 0. Whoops. Or from 0 to 1 would make more sense. From 0 to 1. It can be 0 and it can be 1. So it's from 0 to 1. The probability can be written as a percentage, a percent. The higher the probability, the more likely an event is to occur. The lower the probability, the less likely the event is to occur. And equal probabilities means that the events are equally likely to occur. Okay, so go do the practice, mark it, do your corrections, and I'll see you on page 6. Okay, one quick example here, but in the middle of your practice work. It says in a game, the probability of winning is 1 out of 5. How many times could Lisa expect to win if she plays the game 85 times? We have the probability of the event times the number of tries. So we would have the probability of winning is 1 in 5, and we would multiply that by 85, which would be 17 times. We would expect Lisa to win 17 times. Okay, finish the next page or so of work and I'll meet you on page 8. Okay, now we have the rule of subtraction, which is when things are not happening. So the probability that an event doesn't occur is equal to 1 minus the probability that the event does occur, or 100% minus the probability that the event does occur, because the event either occurs or doesn't occur. Okay, so let's do some examples. Suppose the probability that Bill will graduate from college is 0.8. What is the probability that Bill will not graduate from college? So we would go 1 minus 0.80 equals 0.20. So that's the probability. There's a 0.2 probability that he will not graduate from college. If it had been written, if his probability that he was going to graduate was written as 80%, we would then go 100% minus 20%, sorry, minus 80%. 80% equals 20%, which is of course the same as 0.2. It's just written in a different shape. That's all. Okay? All right, do this table and I'll see you on page 9. Okay, this is the rule of multiplication when two things are both going to happen. So the probability that multiple events both occur is equal to the individual event probabilities multiplied together. For example, an urn contains 6 red marbles and 4 black marbles. 2 marbles are drawn without replacement. And that without replacement and with replacement is really important. What is the probability that both marbles are black? So we have draw number 1. There are 4 blacks, 4 black marbles out of a total of 10. So that's the first draw. And then in draw 2, there are 3 black marbles left. Out of 9 total, because 1 is missing. So the probability of black and black is 4 out of 10 times 3 out of 9, which is 12 out of 90, which reduces to 2 out of 15, which is 0.133, which is 13.3%. Okay? Okay, another example. Jacob is buying ice cream. He can choose one flavor of ice cream, chocolate, strawberry, vanilla, or Rocky Road. He can put his ice cream in a sugar cone, waffle cone, or a cup. What's the probability that Jacob will choose chocolate ice cream in a waffle cone? Now, we're going to just pretend he's choosing randomly because if he's got a favorite, it's not going to be probability, right? So he can randomly pick any of these combinations. So the answer is going to be so what's the probability that he's choosing chocolate times the probability of a waffle cone. So the probability of chocolate, there's 1, 2, 3, 4 choices, so it's 1 in 4, times the probability of a waffle cone is 1 in 3, so that gets us 1 in 12, or 0.08, which is 8%. Okay? For the next questions, you are asked to give all of your answers as a fraction, a decimal, and percent. So that means you need to give all 3 of these answers. Okay? Okay, go do your work and do your marking, and I'll see you on page 11. Okay, now we're on page 11, and this should actually say with replacement. We're actually going to talk about with replacement, not without. Okay, so can you fix that on your notes, please? Faith is drawing 2 cards from a deck of cards with replacement. That means that after she's drawn the first card, she's going to put it back in again and then draw her second card. So what's the probability that the first card is a heart and the second is a spade? So we want the probability of a heart times the probability, of a spade. So there are 52 cards in a deck, and 1/4 of them is each suit. So this is going to be 13 out of 52. 13 cards out of the 52 are hearts. And then if you put that back, we again have 52 cards, and 13 of them are spades. So we multiply that, we get 169 over 2652, which is 0.06, which is 6%. Okay? We could have also done this as 1/4 times 1/4 is 1 over 16. 0.06 equals 6%. That would probably be better because this fraction is reduced. Okay, second example. Shakita is drawing 2 cards from a deck of cards with replacement. What's the probability that the first card is red and the second card is black? So we've got the probability of red times the probability of black. Well, they're half and half, right? So the first probability that the first card is red is 1/2, and the probability that the second card is black, if we've put them back, okay, we've put our first card back, that's going to be 1/4, which is 0.25, which is 25%. Okay, there's your answer. All right, so you've got a couple of pages of practice to do, and I will meet you on page 17. Okay, we're going to look at this Venn diagram showing the probability of event A and event B. So the probability of just A happening is the yellow part, or this part here that I'm going to color in yellow. Okay, that is just A. And this 0.1 part here is A and B happening because they're overlapped in the Venn diagram. So the probability of A happening is 0.5 plus 0.1, which is 0.6. Okay, the probability of B happening is this part here, the 0.3, plus, and this blue part here is where just B happens, only B happens there, plus the overlap area where A and B both happen. So the probability of B is 0.3 plus 0.1, which is 0.4. And the probability of A and B is 0.1. We can just pull that right off the diagram. The probability of A or B is the probability of A, which is 0.6, plus the probability of B, which is 0.4, minus the probability that they both happen, which is 0.1. And the reason you need to do that is that we've counted this green part twice, right? It got counted once with the A, it got counted once with the B, so we need to subtract it, okay? And our answer here is 0.9, okay? The other way that you could calculate it given this diagram is we know that we can look at the probability of just A, which is 0.5, and the probability of just B, which is 0.3, plus the probability of both happening. And that gets us 0.9. But that's not using the formula that we're given up at the top. This uses the formula that it's the probability of one event plus the probability of the other event minus the probability of them both happening. All right, what's the probability of A and not B? So A and not B is the just A, right? So that's 0.05. Or sorry, just 0.5. And the probability of B and not A is just the blue area, which is 0.3. And the probability of neither A nor B, well, there's two ways we can calculate it. We can go that it's not A or B, so it's going to be 1 minus 0.9 because we had 0.9 as the probability of one of them happening. So that equals 0.1. We can also just go up to the drawing and see that there's a 0.1 right here, which is neither of them happens. Okay? Okay, one more example here, and then you get to do some more practice. A student goes to the library. The probability that she checks out a work of fiction is 0.4, and a work of nonfiction is 0.3, and both fiction and nonfiction is 0.2. What's the probability that she checks out a work of fiction, nonfiction, or both? Okay, so it's going to be fiction plus nonfiction minus both because we've counted both twice. So the probability that she's going to pick out fiction is 0.4, probability of nonfiction is 0.3, and the probability of both is 0.2, so we need to subtract that, and that gives us 0.5. Okay. Yeah, that's not a great example because it's not, I mean, she's picking multiple books, but the process works, okay? You do that, it's the probability of one plus the probability of the other minus the probability of both. Okay? Do your practice and I'll see you on page 19. Okay, using Venn diagrams instead of the rule of addition. This sometimes helps things make more sense, I think. So when you're doing a Venn diagram, you always want to put a box which is everybody, okay? And the probability inside the box is 1. So 40% of homes have a pet dog. So let's do this. And this is dog, and it's 0.4. And 30% of homes have a cat. So this is cat, and that's 0.3. And 40% have neither a cat nor a dog as a pet. So that's this area out here. This is the 0.4 out here. Okay, and So what we need to do is how many homes have both a cat and a dog? We're looking for how much is in here. Okay? So we have to figure out it's going to be 0.4, which is so it's dogs plus cat minus both plus neither has to equal 1. Okay? Because the dog, this drawing's a little bit different because this time the 0.4 is referring to this whole section here. It's all of the dog possibilities. Okay? And the cat is referring to all of this. I love how it conveniently combines the colors for me. This is the cat. But if we add up the dog and the cat and the neither, we've actually counted this green bit here twice, so we need to subtract it, and that's the both. That's the both area. Okay, so let's put some numbers in here. The dog is 0.4, the cat is 0.3, minus we don't know, plus the 0.4 for neither is 1. So we get 0.4, 0.8, 1.1 minus x equals 1. So x equals 0.1. Okay, so the probability of it being both is 0.1 or 10%. Okay? Okay, that's it for the probability section of this. So go do your work and check your answers and go write a quiz. All right, bye.